All right, you are live and on stage, Tom.
Okay. Well, thank you, Todd. Welcome to everybody, and thanks so much for signing up and tuning in to the History of Rocketry. I had a really good time putting together this presentation. In fact, I learned quite a bit myself. I never paid much attention to history going to college and high school. All of my electives were, drafting and auto shop and metal shop, things like that. So this experience of history was a lot of fun for me. And Todd spent the day yesterday with me working out all the bugs. I wouldn't be here without the help of Todd. So thank you very much, Todd. Um, I don't know how many people of what ages are listening in, but I'm going to assume that there's ages from 15 to 80. So I'm going to assume that everybody doesn't know about the 50s and 60s um, and what we had to go through when we were younger to build these rockets and all of the hoops that people had to jump. So you're going to get exposed to some of this stuff in history. And if you have any questions, please just type your questions in the communications box there, the chat box, and we'll go over questions at the end of the presentation. And so let me start out right now. The history of rocketry in the beginning. So in my class at San Jose State, I had one day when I says, "Hey, does everybody remember Mesopotamia?" And the class went into hysterics. They says, "What does Mesopotamia have to do with rocketry?" And I said, "Hang in there, I'll get to it." So in the beginning, the people lived as hunters gatherers, subsistence living, and the agricultural revolution happened in Mesopotamia. The agricultural revolution enabled humanity to be able to exist on a large scale, build things like the pyramid. So it changed the whole thing for humanity. And thousands of years later, we had our second revolution, and that was the Industrial Revolution. And you've all seen what happened as a result of that. Well, right now, we are experiencing a third revolution, and that is technology, electronics, the electronic revolution. That started, I don't know, 40, 50 years ago, 30 years ago, but it's just exploded. And look at how that's changed our lives. Well, you go for a couple thousand years to have a revolution, and then you go a couple hundred years, and then 100 years. What we're seeing right now is two more at the same time. You have the biotech revolution, and you have the space revolution. So, what an incredible time to be alive is to witness three of these life changing events, revolutions for humanity, all happen at the same time. And I just wanted to let everybody know that the rocketry is just exploding. We're going to be going to different planets, and it's really fun that you're all involved with rocketry. I sure like it. My name is Tom Rouse, and I have been a rocketeer for, geez, since 1998. I went out to Black Rock. In Black Rock Desert, we started a program with Stanford University called ARLIS, and I'll be doing a presentation after this about ARLIS. And that's where we launch rockets for students around the world that come on out and they put satellites in it. We go up about 10,000 feet. In the early 90s, late 90s, we noticed that rockets were crashing all the time when they would go high. So I invented the CO2 system. The CO2 device is a ejection system that uses CO2 gas, cold gas, and it punctures the CO2 cartridge and pops your parachute out. Which the nice feature of it is it doesn't burn your parachutes, but it also gets your rocket to deploy things over 20,000 feet. I served on the Tripoli board of directors. I launched a rocket to 90,000 feet where I made my own fuel and made the rocket out of carbon fiber, went Mach 3.2. I just love rocketry, and presently I retired from my home building business and I teach at San Jose State, working on a propellant class. So rocketry's in my blood, just like you guys, and thank you for tuning in. The beginning of rocketry had its seeds in China in 900s. The Chinese were using gunpowder and they discovered it started to flame and burn and all kinds of stuff. And they thought, wow, this is magic. So what use can we use for gunpowder? Originally, it was used as an elixir to, lengthen your life or to cure headaches or whatever. It was a cure-all. And until they started figuring out they could use it as a flying fire, a flying projectile. And that's when it started being used as a rocket, quote unquote. Now, the Mongols started looking at it, India, Middle East, Korea, and then in 1380, Europe started taking notice of what these things could do. I'm going to show you some drawings. These are the early drawings of the Chinese and what they were used as what they call flying fires. See the drawing on the right where you see the fire looks like doves? Subsequent after the flying fires, they started calling them flying doves. And I think the reason they did is because of these drawings looks like a bird. But basically, they're bottle rockets. In 900, they invented the bottle rocket. And not much happened for 1,300 years, just the same old bottle rockets. But in 1600s, there was a Polish artillery guy that started using these bottle rockets as staged and used them for artillery in Europe, stepped it up. And Isaac Newton was born in 1643. So there was a lot of growth happening. And why was this growth happening? Because the Black Death in the 1400s killed off a third of Europe. And before that, everybody lived in a fiefdom type of environment where you had no time to do anything. All of your profits were sent to the kings, and you couldn't own your own land. So it was a really tough time. After a third of the population died out, then you had the Renaissance, the artwork, the sciences, because people could own their own things and you'd have enough time to do stuff. That really spurned the development of a lot of stuff, including rocketry. There was an English admiral that went down to the Indian wars, the Anglo-Mysore wars, and he saw the Indians using these bottle rockets, these rocketries. And he says, wow, look at this. And he refined them and started up a rocket company. Now, his rockets were used in the War of 1812 at Fort McHenry. Now, the Star Spangled Banner, the rocket's red glare, these were Congreve's rockets. Now, you can see that they're basically the same thing from the 900s, bottle rockets, but he put them in steel casings. And you know what happens when you put gunpowder in steel casings. So they did a lot of damage. They were also used in the Battle of Waterloo in 1815, and that really kind of put the end of Napoleon's army, and it ended the Napoleonic Wars. I found this picture here, and I really find this picture, it's pretty cool. I'd put that on my own wall if I could find it and frame it. A nice picture. All along, they were used as artillery, as a weapon. There was no reason to think that rockets, bottle rockets, could be used for anything other than artillery or a weapon. So for all of these 900 years, that's what it was. In the late 1800s, guess who? That was Goddard. Konstantin Cholovsky and Robert Goddard were both started their work in rocketry during this period. They both were instrumental in the foundation of today's rocketry. With the wars, World War I and World War II also led to the V2, but that led to the funding of all of these projects because everybody says, well, rocketry is a weapon, so let's get bigger weapons. Let's get more powerful weapons. So they gave Goddard a lot of money to do research and development. He started a book called A Method of Reaching Extreme Altitudes, and that's why he is known as the father of modern rocketry. He began an analysis of rockets. He started out with solid fuel first, and then he went on to liquid fuel. He had a synopsis where he says, first, fuel should be burned in a small combustion chamber instead of building the entire propellant container. And I'm not sure exactly what that means, but subsequently to that, he went to the use of the nozzle, the De La Velle nozzle. Now, we all know what that is now, but they didn't have this back then when he started. I don't know what they used for nozzles, maybe just a bulkhead with a hole. But this nozzle increased the efficiency from 2% of these bottle rockets or whatever they're using before to 64%. So you have your convergent divergent nozzle, which we all know today is just the standard of a nozzle, but that wasn't known back then. Goddard started employing that and doing fantastic things with it. That which led to him starting to work on liquids. One thing he was noted for is he started basically with the funding he got from World War I, the creation of the bazooka. So he was the father of the bazooka. Kind of interesting. And that book I was just mentioning, The Method of Reaching Extreme Altitudes, the Smithsonian published that in 1919. You can see this is all during the war. He got a lot of funding, and which enabled him to do a lot of work. 1921, he started experimenting with liquids. Here's a video of him, if I can get this to work. I don't know if it's going to work. I had to, nope. Well, it's not going to work. Sorry about that. I did this presentation in Apple Keynote and had to switch to PowerPoint to get it to work with Todd. So I guess I have a glitch in that video. In the 30s, the Guggenheim saw the promise of rocketry, and they gave Goddard quite a bit of money. And Goddard moved to Roswell and started building his rockets in Roswell. After that, in the 30s, the Russians were experimenting with rockets, and Werner von Braun was awarded research grants from the German army. And there was a Russian scientist that his identity was kept secret. Not even the people that worked with him knew who he was. He was so valuable. And one of the reasons that people say he was so good was back then he was known as a systems engineer. Well, today that's commonplace because the world is so complicated. You need to, if you're into rocketry, you need to know about propellant, you need to know about airframes, you need to know about telemetry, you need to know about recovery. So you need to be a systems engineer. You need to understand everything when it comes to rocketry. But back then, people were specialized. So that was one of the successes of him, and which led to him building the Sputnik and being the father of all rocketry in Russia. Pretty amazing guy. The Redstone. After World War II, the government wanted some ballistic missiles. They were afraid of the Soviets. So they did the Redstone project, and it was a spin-off of a Operation Paperclip, which was an Army thing to build rockets for our defense, based on the V2, the knowledge and the operation of the V2. They stationed them in West Germany. The rocket was powered by LOX and 75% ethyl alcohol and 25% water. Now, I think the water was to keep it cool because of the nozzles. I'm not sure, but it's kind of an interesting combination. In the 60s, the Mercury program, Redstone rockets were used in the beginning, but were later replaced by the Atlas. Now, the Atlas rocket was a real problematic rocket, and I'll get into that in a second. But the Redstone was made by the hundreds and hundreds as an ICBM, and some of them were used in the Mercury program initially. The Mercury had LOX kerosene, and LOX kerosene, which is RP1 basically, was used for years and years and years on all kinds of other rockets, still is used on rocketry. The Atlas, all right. This was the Mercury rocket replaced the Redstone. Now, that was LOX kerosene also, and there was a test launch where some Gemini rockets, Mercury rockets, astronauts were at the launch site witnessing a test of this rocket because they were going to be sitting in it and going up in space. And it blew up. It didn't give them much confidence. The Atlas rocket blew up quite a bit before they perfected it. I don't know how many guys are familiar with micrometers, but the thickness of the skin of the Atlas rocket was 14 thousandths to 37 thousandths. A huge rocket. That's almost paper thin. It's just unbelievable. I don't think the rocket could have stood up on its own. It would have crumbled without being pressurized. They had to pressurize it with nitrogen. But instead of having a skeleton on a rocket with the fuel tanks inside, the skin of the rocket was the fuel tank. And they really did a lot of engineering on this. They went to the nth degree, law of diminishing returns, where they said if the skin weighed the skin weighed 2% of the fuel carried. If the skin's thickness varied by as little as 1/1000th of an inch, the weight would increase by 100 pounds. What's 100 pounds? No big deal. But the range would decrease by 100 miles. So 100 pounds equated to 100 miles in distance. So you can see how they just really got down to the nitty gritty on building this rocket. It wasn't a success story at the beginning. So I'm going to see if I can get this to work, and hopefully Todd's listening in. There we go. Here's one of the first tests. So you can see, watch this. Back then, rocketry was pretty tough. This was cutting edge technology on the Atlas. There we go. This is it from there we go. It went up just a couple feet and came right back down. Okay. Here's another one.
After nearly a year's delay posed by its liquid hydrogen fuel, the mighty Centaur is on its pad at Cape Canaveral for a maiden flight. It is to be boosted into space by an Atlas for a 15-minute flight, a flight scheduled to study the performance of the temperamental hydrogen fuel. The Centaur is designed to put a payload of more than a ton on the moon, or 1,000 pounds in the vicinity of Mars or Venus. The first few seconds of the shoot go without incident. The Centaur climbs to 30,000 feet, then malfunction.
Looks like Black Rock Desert in the summer.
The immediate cause of the explosion is not known. But if it happened in the Atlas booster, it means a probable delay for the next U.S. orbital flight by astronaut Malcolm Carpenter. Long-lens cameras capture pieces of the wrecked missile falling into the sea, falling like a wounded bird. However, in the race for space, scientists find progress in every failure.
That's the way people talked back then. It was funny. I don't know how many people my age are watching, but this was black and white TV, and this was the way it was. This is the stuff we saw when they went to the moon, the type of black and white. And here's a video that won't play. I don't know why. Probably got it from a different source. Here's one more I just wanted to show you. And these videos won't play. I should have, sorry about that. Well, anyhow, you get the picture of the Atlas and its problematic beginning. So this, after that, the 60s was the renaissance of rocketry. That's when the space race happened. The Mercury program, the Gemini program, and the Gemini program was a bridge between Mercury and Apollo for testing spacewalks and time in space and all kinds of things. It was a great, great program. And they used the Titan rocket for that. So I'm not sure if you're all familiar with the Titan rocket, but it was a hypergolic fuel rocket, which means it didn't have oxygen at all. It had aerosine 50 and nitrogen tetroxide. When these two chemicals combined, they would burn and produce a lot of thrust. Here's a picture of the Titan taking off, and take a look at the exhaust plume. There's barely any smoke at all, which is really interesting. And it had two motors. The primary purpose of the Titan was the ICBM, but they adapted it to use in the Gemini. And today there is silos all over the country that you can go through that had these Titans in them, ready to go for the ICBMs. The UDMH, unisymmetrical dimethylhydrazine and nitrogen tetroxide. pretty dangerous stuff. It's not even considered as a fuel today, except the SpaceX uses it. Here's a silo test of the Titan. It's amazing, huh? I don't know where all the smoke is from because the plume doesn't create any. So there it is, the Titan being launched as an ICBM out of a silo. And then comes the Apollo, the Saturn V, the big daddy of all rockets. They proposed to build that with Wernher von Braun early in the space race. The consideration was to use, if the first stage had used liquid hydrogen, see, the first stage used LOX kerosene, RP1. But if they had used LOX and hydrogen, the volume of the boosters would have been more than 3 times greater, because the hydrogen is so lightweight that it takes up so much more volume, which would make the rocket aerodynamically infeasible. So that's why the booster on the Apollo was not LOX hydrogen, it was LOX kerosene for size. Pretty interesting. You know, like I say, this is the renaissance of rocketry. They experimented with everything. This was a national effort. It's similar to war. I don't know how many people are like my age or whatever, but the 60s, rockets were huge. I mean, the whole country was overcome with the moon landing and the Gemini and the television. So rocketry was a big deal. That's one of the reasons Estes was such a success at the start, is the whole country was enthralled with rocketry. Here's the 70s. Okay, now I don't know if you remember the 70s, but I remember going to school with wingtip shoes on. And then at the same time, you'd have people going to school with bell bottoms on. So it was a real dichotomy of our culture. The culture was changing so fast. And on the left is a slide rule. So all of us are spoiled right now. We have our computers. We can do anything. We have the internet. But they didn't have computers. They didn't have even a calculator, handheld calculator. They had this. Now, you got to see this, because if you don't know what a slide rule is, this is how they went to the moon.
There's a pretty awesome tool that helped land us on the moon. It's called the slide rule. We're going to talk about that next on how we got to the moon.
We choose to go to the moon.
In 1962, when President Kennedy said, we're going to go to the moon, computers looked like this. Phones looked like this. The internet looked like this. Okay, it didn't exist. But pocket calculators didn't exist either. The engineers had to use a special tool to do their mathematics, and it was a slide rule. Now, this slide rule is basically made out of wood or plastic, and it has 3 strips of wood where the center strip can slide back and forth. And you also have this cursor, which has a little line on it, and you can slide that back and forth and line it up with different scales on these rulers to do math. I'm going to show you how. Here, check this out. So let's say we wanted to do a simple math problem, like what's 3 times 2.5? First, you look on the left-hand side of the slide rule, you'll see scales. If you line up the number 1 on the C scale with the number 3 on the D scale, and then you take that sliding cursor and find 2.5 on the C scale, and the answer is revealed on the corresponding line on the D scale, 7.5. Now that might seem like a really complicated way to do a simple math problem, but engineers in the 1960s, that's all they had. And with enough practice, they could do the really complicated math we needed to figure out orbital mechanics and trajectories to get to the moon. With the advent of pocket calculators and computers, there's no more need for the slide rule. Sorry, buddy. It's a cool tool, though. Until next time, thanks for joining me on How We Got to the Moon.
That's pretty interesting. I remember going to college, and one of the first calculators somebody brought into class, and everybody was blown away. In the 70s and the 60s, this is what AutoCAD looked like. You had rooms and rooms and rooms of people drawing plans. I remember going to college and high school and junior high school, and there was class after class after class of drafting. Drafting was a heck of a career. If you were a good draftsman, you could work at all kinds of companies. Every company had to have drafting rooms and blueprints. There was no computers. This is General Motors drafting room, working on cars. Look at that. See how they're all dressed? Do you think that would work in today's world? You have to wear a white shirt and tie. I don't know if that's going to be something that's accepted in today's world, but that's the way it was back then. And I'm sure they have wingtip shoes on. Which led to the 70s, the big daddy of rockets. The Air Force and NASA collaborated to produce the most complex rocket man has ever made, the space shuttle. That's a great picture I found. It wasn't until 2000 that the space shuttle was added a glass cockpit, all digital controls. Before that, it wasn't. Look at the controls on that. When I say complicated rocket, it was very, very complicated. The STS had 135 missions. Enterprise was a test vehicle, and it's at the Intrepid Museum in New York right now. And all of the other shuttles you can see here are on display all around the country in different museums and different places, except for the Challenger. And obviously that one disintegrated, and the Columbia. But you have the Enterprise, Discovery, Atlantis, and Endeavour. So I don't know if you've ever seen a space shuttle, but that should be on your bucket list to go see one of these. They're amazing. There's actually one in Huntsville, Alabama. It's a mock-up of a space shuttle, and you can walk underneath it. That's at Space Camp in Huntsville. That's another fantastic place to visit. They've got capsules for Mercury and Gemini capsules that have flown. They've got in their museums, they have everything there. It's just something you need to go to if you're into rocketry. Here's a comparison of different propellants that have been used in the history of rocketry. Hydrazine produces a ISP of about 292 seconds. LOX alcohol, LOX kerosene, LOX hydrogen. And then the SRBs are about 242, which is pretty high for a solid. Again, when I mentioned that if the Apollo had liquid hydrogen in the booster in the lower stage, it would have been huge. So there's all kinds of decisions that needed to be made in the design of these rockets on what type of fuel to use. I don't know why they came up with hydrazine. It's got 292. It's got a pretty good specific impulse, but not that great. But judging from the dangers and the chemicals of the hydrazine, I don't know why it was chosen. Maybe it was thought to be the next thing. Then we get to SpaceX. You ever heard of SpaceX? Amazing company. They started out with their Merlin 1 motor, the engine, which they developed in 2002. LOX kerosene, same thing, has been used in most of the rockets all along. They didn't have regeneratively cooled nozzle at first, and they used a blade of carbon ablative nozzle. So they upped it and changed it. By mid-2015, SpaceX developed a total of 9 new rocket engines. Can you imagine that? 9 rocket engines in the first 13 years of their company's existence. So they did a lot of R&D, which is way better than what the government does in their projects. ULA, United Launch Alliance, they first launched their rocket in 2002. That's a partnership of Boeing and Lockheed. This rocket was short-lived. It's the Delta IV. It's no longer being used. It was retired. And it was launched in different configurations. They call it the single stick, which they launched the rocket with just the single configuration, and then they did it with the side boosters. All 3 configurations were identical. They used LOX hydrogen, okay? So the only difference between the 3 is the payload on the top of the middle one. ULA then started doing the Vulcan Centaur. The nose cone, I wanted to point that out because that's a power series. It looks like a power series nose cone. So if you want to do some research on nose cones, it's pretty interesting on the shape of the nose cones, and you can get different shock waves on nose cones, and then there's drag characteristics of each shape of nose cone. So between the speed and what altitudes they're going to be experiencing the highest density. So it looks interesting that they chose the power series for this. It'd be nice to do some calculation to figure out the reasoning behind that, whether it was shock waves or not. At the start, the program was plagued with problems. And right here, where I say still has not had a launch, they finally did launch their rocket. I believe it was about a month ago. I did this slide before they launched it. And it went pretty well, but they had a problem with their payload. The second stage uses LOX hydrogen, same as the Delta IV, and it has capability of restarting. Pretty nice rocket. The SLS. I did a whole bunch of work on the SLS, and I don't know where it is on the slide. But from the 60s to now, here's the evolution of rockets and how big they got and what's going on with them. You can see the Apollo down on the bottom compared to some of these early rockets. So we get to hobby and mid-power and high-power rocketry, the history of it. The 1966 Estes catalog was what everybody would look at in the 60s and go buy their rockets and have some fun. It started with G. Harry Stein and Orville Carlisle. They founded a rocket company called Model Missiles Incorporated. It was a short-lived company. They ran into financial problems and the company was folded. The Estes family was contacted by Model Missiles to make the motors. Now, the Estes family was primarily a fireworks-based company in Colorado back then, and that's why they were chosen by Model Missiles, Harry Stein and Orville, to make the motors for Model Missiles. After Model Missiles went out of business, Estes thrived because they were making the motors, and so they started making their own propellant. The current owners, Estes has gone through a lot of changes. A lot of companies have bought them out and merged. The current ownership is a wonderful family. It's the Langford family. John Langford bought it from Hobbyco when Hobbyco went bankrupt. Their family brings a lot of enthusiasm and a breath of fresh air to the rocketry community. It's been a blessing to have them take over. After the GoX plant, the Hogden company, after the GoX plant, I don't know if you call it exploded or burnt down, but it's no longer there. They bought that, the black powder company, GoX, from Hogden, and now they're making black powder, which ensures that they have a constant supply of black powder for their company, which is a great thing for them and the security of our rocketry. Vern started Estes in '59, and he participated with Harry Stein in the formation of NAR. They were the guys that set the foundation for all of the stuff we're doing right now and the presentation we're having today. We owe a lot to them. And Vern still sits on the board of Estes. I think Vern is about 90 right now. I'm not sure. I've never met him. NAR, 1957. That's when you were born. It's grown to be the oldest and largest space modeling organization in the world. I don't know about the word space modeling, but I guess you could call it space modeling because of all the rockets they make. NAR is divided into sections, as you all know, depending on where you're at. Tripoli calls it prefectures, but they have over 200 sections and 9,000 members across the United States. That's quite a bit. G. Harry Stein co-founded NAR, formed Model Missiles. We owe a lot to Harry Stein. He was the grandfather, the father of modern day rocketry. He also was a prolific writer. He served on the NFPA, but he also wrote for Star Trek and was an advisor for Star Trek. And he wrote under his own name and under a pen name. So he loved sci-fi, loved rockets, loved Star Trek. And Star Trek consulted with him on certain episodes on how to do things. He wrote the Handbook of Model Rocketry in '65, which was printed in 7 editions and still circulated today. Then we come to high power rocketry. So we've seen the birth of gunpowder, we've seen the birth of STs, and then comes high power rocketry. You started getting into APCP, propellants, and more bigger motors, and people would make their own motors. Reaction Research Society was founded in 1943. It's in Southern California. They experiment with all kinds, hybrids, liquids, solids, and a very technical group of people, a fun group of people. Tripoli Rocketry, founded in 1964 by Francis Graham. Tripoli is the sister of NAR, basically the same, except for they allow EX propellant to be launched at their launches, which an EX propellant is your homemade homebrew propellant, which a lot of people like to do. And then there's FAR, Friends of Amateur Rocketry in Southern California, that provides launch services and education to people in high power rocketry. The manufacturers of high power rocketry motors. Well, today we've got Aerotech, we've got Loki, CTI, and AMW. Now, if I'm forgetting anybody, I'm sorry, but these are the ones that I could remember that provide our rocketry community with high power motors right now. One person I wanted to point out that everybody knows, but I don't know if he gets enough credit for our current status of high power rocketry. And the reason that we have it so nice right now is Gary Rosenfeld. This is a picture of Gary out at Black Rock Desert in the hamster dance. Naturally, he wins it every year because he makes his own motors, and he can make some pretty exotic long burning motors. But in 1970, at 15 years old, he started doing rocketry. And look at that. It looks like a 4-stage rocket. In 1973, he made his first motor with his college and then his Air Force. And then he started up a company called Composite Dynamics, went to work at Burmite Corporation, and learned a whole bunch. Started working on smokeless sidewinders at Aerojet. Well, when you have a sidewinder go off, you don't want to reveal your location. So you need a smokeless propellant. He started Aerotech, and then he started Aerotech HPR. Here's a Composite Dynamics catalog of 1981 with the thrust curve. These were little motors. This is the way rocketry was back then. Pretty much small stuff. In '73, Composite Dynamics was formed. Here's a test. Here's a data from his first motor test. Kept impeccable records of all of his work. You see that if you look at it, it says where is it? It says the propellant is boat resin. Oh, there it is up at the top. Of boat resin and polyester resin, and I'm not sure. But it was no HTPB back then. And then in 1980, Aerotech was formed. The first motors were E6 and F10 long burning motors. 1990, reloadable motors were introduced. Now that changed everything. The hobby, you would start getting into larger motors, and they were more expensive because they were single use. A lot of work went into involving single use. So the reloadable motors were introduced and invented by Gary and his company, and it changed everything. What it did change was Vulcan. Vulcan was a competing rocket motor supplier in the country. And prior to reloadable motors, there was a 50-50 split in sales between Vulcan and Aerotech. After Aerotech introduced the reloadables, it was 90% Aerotech. So what happened? There was some very bad things that happened to our rocketry community, which could have really changed everything. If this report would have fallen into the wrong hands, or somebody would have listened to this report, we wouldn't have reloadable motors now, and rocketry would be totally different. They did a video and they said, hey, this is the dangers of a reloadable motor. And they sent it to a bunch of government agencies, individuals, and entities. Gary put up a long fight with the DOT and the CPSC that ultimately cleared any violations of this reloadable motor. If these government agencies had said, yes, we agree, these are dangerous, we'd have a different hobby. And Gary was the one that fought and got that changed. So we owe him a lot of gratitude for doing that so we can have our hobby the way it is. This is a low blow. This is a report that could have ruined HPR. And it's signed by Scott Dixon, who was the one that did the report. So he had to deal with that. Other things that he had to deal with in his career was the ATF regulations. I'm not sure if you all remember the ATF regulations, but from 1994 to the end of the lawsuit in 2009, you had to have an ATF LEUP, low explosive user permit, to buy a rocket motor. And that meant that the ATF could come to your house and look at your house and see what motors you have. That really deterred, and it really hurt the hobby for a long time because people didn't want the ATF coming into their house. Then Gary had the fire, and that was in 2001. And you can see Joe Berger standing in the aftermath. So those three things pretty much would have crippled a lot of people. He persevered and is still there. The rocketry community, the business, the history of rocketry, there's so many companies that have come and gone in these last couple of decades. And since I've been doing it 20 some years, these are the companies that are no longer around that were in existence when I started. You know, look at that list. It's just an amazing list of companies that come and go. And we have one company that's still in business, and that's Aerotech and CTI and some of the others that are around. In the beginning, it was in the early 80s. Like I said, it was small motors. You'd have F-10s. And just like the history of rocketry, where they started out with bottle rockets and they ended up with the space shuttle. So our hobby has evolved from F-10s to larger motors. When we were out in Black Rock, people would come out and launch ABCs motors. And then you'd have a guy launching an N motor, an O motor, a P motor. Excuse me. And we would joke and laugh and hoot and holler about the smaller motors were basically igniters for the big motors. So we would call them igniters as a tongue-in-cheek reference to the relativity, the size of it. Here we go. Now, this is what we call an igniter. And tongue-in-cheek again, this is an O motor, which could be used as an igniter in the space shuttle. But anyway, that's how you look at it. This is Gary on the left, John Lingdahl, Carl Baumann, and Kyle Anderson sitting there ready to test the O motor. And here we go with the pretty amazing, huh? So your Team America Rocketry Challenge, your TARC motors, this is what you have to look forward to if you keep it up. You know, you keep experimenting, you keep trying, you keep pushing yourself, you keep going bigger, and this is where you end up. Luckily, that concrete wall was anchored because that was an amazing test. One thing that's I wanted to point out, the Aerotech makes over 400 motors. They've been around since the 1980. They've had to deal with all of these problems and government attacks and LEUPs and other people. You know, when you're at the top of the flagpole, everybody always attacks you. But they have a company now that makes over 450, 500 motors. Look at these. Look at that. How many sheets of motors is there? H's, J's, 54 millimeter, 75 millimeter. It's amazing. So they provide a great service to our hobby. Could you imagine if we didn't have reloadable motors? If the fight wasn't won, could you imagine if we didn't have a choice of 500 motors, what our choices would be? It would be pretty minimal. I'm sorry about the I did this presentation in Keynote and I switched it over to PowerPoint. and I lost a bit of formatting. I'm sorry. But also Gary's service to HPR. He served on the NFPA. Harry Stein asked Gary to join and represent composite propellant in rocketry. You know, Gary was the first person in the U.S. to make APCP propellant, and back in the 80s. He has served since 1983 on the Pyrotechnic Committee for 1127, 1122, and 1125. 1122 was created by Harry Stein. NAR and Tripoli NAR has 9,000 active members, and Tripoli has got about 6,000. So without a good motor supplier, without good kit manufacturers, without good supports from other people, our hobby would be vastly different. And so I just wanted to acknowledge what Gary has meant to the hobby. And I don't know if you've ever met him, but it's remarkable what he's done behind the scenes to support all of us. You got 16,000 members, all the different kinds of motors and all of the different things he has provided our hobby to make it as nice as it is. I think he should be up there with Harry Stein and Estes as that important to our hobby. And I guess it's time to say goodbye, guys. I want to say thanks to John Hockheimer, whose nickname is Hoochie Mama, Todd, who really did a good job in helping me, Ed LaCroix, and Becky Green for nominating me to do this presentation. So if you have any questions, I'd love to hear them. Todd, are you there? I think Todd's going to be here in a minute. Okay, here we go. Thank you, Robert. It was a fun project to put together for you. I wish I can say, you could do a PhD in any one of these subjects. So I just kind of skimmed the surface, but I thought it was pretty interesting. I'm glad you liked it. John says, I remember the days of getting a layup and you never got one. I don't blame you. Most people said I didn't want to get one either. You're welcome, Tim. Thank you. Thank you too. Thanks for tuning in. And again, I'm sorry about the format problems from switching over from Keynote. All right, guys, I guess that's time for me to sign out and say goodbye. Thank you very much. Have a wonderful day. And I'm glad you enjoyed it. Bye.